Alright, this is part 2 of XEI 303. So these are going to be focus and context questions, meaning you're going to see that you're going to have to combine like terms within a real-world scenario. So here the problem says one side of an equilateral triangle is 3x minus 4 units long. Write an expression that shows the perimeter of the triangle. Now you have to know that in an equilateral triangle all three sides are the same length. So if I wanted to draw a picture of that, remember we can show that all three sides are the same length using those tick marks. If one side is 3x minus 4, then all of the sides are 3x minus 4 units long. Now we could combine like terms by adding all three sides like this. Okay, and in that case we would add 3x 3 different times. So 3x plus another 3x gives me 9x in my calculator. I just type in 3 plus 3 plus 3. And then for the numbers, here I have -4, -4, and -4. So I would type in -4 minus 4 minus 4. That would give me -12. So I have 9x minus 12 is the full perimeter of the triangle. Now, a faster way to do the same question would be to say you have three sides that are all the same length. So I'm just going to multiply 3 times 3x minus 4. So here I'm using the distributive property. Now I like using this because it is a little bit faster. I don't have to write all of that out. And I get the same answer. So 3 times 3 gives me 9x. 3 times -4 gives me -12. And there's my final answer, which is the same as our first one. So our perimeter here is 9x minus 12 as well. Now in the next question, this one's a little bit trickier. It says Miss Davis has 14p plus 2 pencils to give to her students. One day in class, she hands out 8p minus 3 pencils. Write an expression that represents the amount of pencils that Miss Davis has left. So you need to make sure that here you're subtracting. We are going to take the amount I start with, so 14p plus 2, and we're going to subtract from that amount 8p minus 3. So in this case, this will show what's left over. Okay, that'll give us the leftover pencils. So this expression would give us the leftover pencils. Now what I'm going to do is just basically distribute like we did in a problem before in part 1. So here there's a positive 1 out front. Now when you when you distribute by a positive 1, it doesn't change that problem at all. That expression stays 14p plus 2. So I don't even really need the parentheses here. I can just drop them. Now in the second set of parentheses though, here I have a -1 I need to distribute. This will change. Remember the inside changes to its opposite. So it becomes -8p plus 3. And then after this I'm just going to combine like terms. So I have 14p and -8p. I type that in my calculator. 14 minus 8, that gives me 6p. And then after that I'm just going to cancel those out. And then I have a plus 2 and a plus 3. So positive 2 plus 3, type 2 plus 3 in your calculator, and you'll get 5. So this is the expression of the pencils that are left. So this is the number of pencils that are left over. Alright, we're going to finish off this lesson with our extension skill. In number 9 it says find the difference between the expressions 2x minus 4 plus 3y and -3x plus 2y minus 6. Notice that they're both in parentheses. Now we have to understand what this is even asking. It says find the difference. Now from our previous lessons we know that when you find a difference that just means you're subtracting. So I'm going to take the quantity 2x minus 4 plus 3y. So I take this first set of parentheses and I subtract, because I'm finding the difference between the two, I'll subtract this second quantity here, -3x plus 2y minus 6. Now remember that this first set of parentheses here has a positive 1 out in front. That 1 doesn't really change anything on the inside even after I distribute it. So I actually can just drop the parentheses in this case. Okay, and I don't even need to practice distributing because it just stays the same. 2x minus 4 plus 3y. So I just drop the set of parentheses. Now in the second part here, when I distribute that -1 here, remember this just changes everything to its opposite. So it becomes positive 3x, -2y, and positive 6. And then after this, I'm just going to combine like terms. So I see I have 2x, a positive 3x, which I'll type in my calculator as 2 plus 3. That gives me 5x. Then I have this -4, so let's cancel those. I have this -4 and a positive 6. -4 plus 6 gives me positive 2. Cancel those out. Then I left with the y's here, so I have a positive 3y and a -2y. I'll type 3 minus 2 in my calculator and I get 1. So that gives me 1y, which I'll just write as plus y. This is positive 1y, which I'm just going to write as plus y. Now let's put that in standard form. Let's do it over here. Remember, standard form, we're going to do it in alphabetical order, so we have 5x, and then the y would come next, and then the number is our last term, so 5x plus y plus 2 is my final answer because none of these can be combined. They're not like terms. Okay, next up is problem 10, which says if f of x comma y is equal to 10x minus 3y, and g of x comma y is equal to negative 2x minus y, write a simplified expression that represents f of x comma y plus g of x comma y. Now I know this looks confusing because this notation is totally new to us, but that's okay. Remember, all you want to do is take f of x comma y, that quantity, which we have right here. That's this quantity right there. Remember, that's defined as x comma y, f of x comma y. So I take that quantity, 10x minus 3y, and I'm going to add to that, so plus the quantity g of x comma y. So g of x comma y is this quantity here, so I'm going to add negative 2x minus y. Okay, I could put those in parentheses. I don't really need to, so let's just get rid of them for a second. But really, all this is an example of combining like terms. So here we have 10x minus 3y. I'm just going to drop those down. And then because I'm distributing a positive 1 here, remember, it doesn't really change the inside of that parentheses. It just stays negative 2x and negative y. Now I combine like terms. I have 10x and negative 2x. Type in 10 minus 2 in your calculator and you'll get 8x. Then negative 3y and negative y. Type in negative 3 minus 1. Be careful that there is a 1 here. Okay, so you definitely have a number there. And you end up with negative 4 attached to the y. So this is my simplified expression here that represents f of x comma y plus g of x comma y. So this is the same expression here. Okay, we're going to finish off the lesson with example 11a and b, and then you'll try the rest of the problems on your own. Now in 11a, this is the same kind of question. Okay, we're going to finish off the lesson now with 11a and b, and then you'll try the rest of the problems on your own, and then you'll get your notes checked off. Okay, so let's try number a here, letter A. In this example, the problem is very similar to what we've seen before. We have a set of parentheses minus another set of parentheses, so we know we are going to use the distributive property. Now when I distribute this 1 out in front here, remember it doesn't change the inside of this, so I can just drop the parentheses and keep the inside the same. That's going to stay 3xy, and this term will stay positive 2y cubed. Now the second set of parentheses though has a negative 1 out in front, which will change both of those terms when I distribute. It'll make both of those become their opposites. So instead of positive 8y squared, now it becomes negative 8y squared. And that 4xy changes to negative 4xy. Now when I look for like terms here, the problem is an extension problem because they're a little bit more difficult. What you're looking for is the variable term to be the exact same. See how I have an xy here and I also have an xy here? These would be like terms because they have the same exact variable expression. So in my calculator, I type in 3 minus 4. 3 minus 4 gives me negative 1. So I have negative 1xy. I can write the negative 1 in front, but I don't have to. So I'm going to keep it as just negative xy. So that takes care of these two terms. Now here I have 2y cubed. And I don't have any other like terms with that 2y cubed because this 8y squared here does not have the exact same exponent. So they're not the same like terms, so I don't combine those. And I'll keep 2y cubed and just drop that down. So that one's gone. And I'm going to do the same thing with this negative 8y squared. So negative 8y squared here is my my final answer. Sorry, should be negative xy plus 2y cubed minus 8y squared. Sorry, this negative one was not part of the original problem. That was just the scratch work to show you what 3 minus 4 was. So I should have erased that. So anyhow, this is the last answer that you need to put down on your paper because it's in descending order where you have your highest exponent here. It's also in alphabetical order as well. So I've got the x term, xy term, and then a y to a higher power, and then a y to a lower power here. So this is my final answer written in standard form. Alright, last up is B. Now in B, this is a little bit more complex, obviously, because I have a set of parentheses there are 3 terms in each one, so let's work on this one. Now in the first example, or the first parenthesis, I have a negative 1 here. I'm going to distribute that negative 1 to each of those terms. Remember, it changes it to its opposite, so this 2x cubed becomes negative 2x cubed. This negative 5x squared becomes positive 5x squared. And this positive x becomes negative x. Now in the second set of parentheses, I'm going to distribute a positive 3 to each of these terms. So I get 3 times 3x cubed, which gives me, 9x cubed. So I just multiply 3 times 3 and I attach the x cubed there. Then I'm going to do 3 times negative 2x squared. So I take 3 times negative 2, that gives me negative 6, and I just attach the x squared. Then I'll take 3 times this negative 4 here to give me negative 12, and I'll attach the x. Now I look for like terms. So here I've got, let's do this one in purple, I've got this negative 2x cubed and a positive 9x cubed. So I'm going to type in my calculator, negative 2 plus 9, that gives me 7. So I write 7x cubed. It's positive, so I just keep it 7x cubed. So these terms are done. I'm going to erase that work here. Now I have 5x squared and negative 6x squared. So in my calculator, I'll type in 5 minus 6. That gives me negative 1. So that gives me negative 1x squared. Again, I don't need to write the 1 out in front, but I can if I want. Then I'll cancel those terms out because I'm done with them. Then I have negative x minus 12x. In my calculator, remember this is a negative 1 here, so I'm going to type in negative 1 minus 12. That gives me negative 13. So I have negative 13x. This is my final answer. Remember, I can't combine any of these because even though they all have x's, they don't have the same exponent, so these are not like terms. So that would actually be my final answer here, is just this expression, 7x cubed minus x squared minus 13x. Alright, that is the end of lesson XEI 303, part 2. So go ahead and get started now on the You Try problems. Finish those off. If you get confused, remember, go back and look up, because those problems are very similar to the ones that we just worked on together. Alright, nice job, and get your notes checked.